Every class is recorded.
That's not true, actually. Miss Jambo doesn't record our class.
Yeah, she really does.
I wonder why.
Why would she not? She has to. She has to post. She has to because that's how she posts it to the kids that aren't here.
She posts the other 9th grade class.
Really?
I do that sometimes, but I record everything. But I will only post one if I teach 2 of something. All right, Rowan, close the door for me, please. Well, I only teach 1 Algebra 1, so yeah. And technically, Haley is the only one that's e-learner, and she's here every day. So actually, I don't have to post anything for this class, but I do.
Yes, I am. I am the e-learner on here.
There you go. All right, questions on the homework? Right there. It was full at the start of the day.
Was it?
I filled it up last student advisement. No, I got to fill it up.
Yeah, because we got yelled at last time. Our teachers got yelled at. Josie, wake up. Do you see the cups that they gave us?
Bring your water.
Not even the luxury. No. Get the bottom. I will.
Okay, quiet please. Haley, what's up? All right, just by student advisement, make sure I have it in my box, okay? All right. Okay, voices off, please. Voices off. All right, shh. Any questions? All right, let's grade this. Here we go. Now, as your complaints from numbers 2 through 8 resounded in my ears yesterday, they all have 3 parts to it. All right. Oh, they were complaining that 2 through 8 had 3 parts, so it was only 4 problems that had 3 parts. All right, number 2, A is 20, B is 100, C is 100. Number 4, A is 24. Please be quiet. Grade your homework. A is 24, B is 216, C is 216. Number 6, A is x to the 11th, B is x to the 28th, and C is x to the 28th. Number 8, A is 64k to the 30th, B is negative 64k to the 30th, and C is negative 2k to the 30th. Number 10, negative 32t to the 5th. Who put negative 2 to the 5th, t to the 5th? It's the same answer. They just, like I said yesterday in class, the book will typically write the number instead of to a power. They will go ahead and expand it out and get to an answer. All right. Number 12. Is the door unlocked, Rowan? Okay. Number 12. 125 x to the 3rd. Did anybody put 5 to the 3rd, x to the 3rd? Well, that's what 125 is. Okay. Number 14, and I will stop saying this. So if you got an answer, a whole number to a power, you'll know why when I call it the answer. Number 14 is 36x to the 6th power. Number 16 is 16t to the 16th power. That's a lot of 16s. Number 18, 32, x to the 10th, y to the 5th. 20, 125, p to the 9th, q to the 12th. 22, 243, that's what 3 to the, what, 5th power is? 243, c to the 5th. 24, 8y to the 7th power. 26, 16, x to the 10th, y to the 16th. And 28, last one, 10, x to the 9th, y to the 7th. That's it. Yeah. All right. For me, today is the first real day of Algebra 1. Chapter starts off with, okay, this is where Algebra 1 gets hard for those of you, but for some of you, you've seen some of this stuff. Today's the new stuff. New stuff. If you've been paying attention for the last, I don't know, 2 days or so, you're going to kill this stuff. This stuff is going to be so easy. If you were not paying attention to the last couple of days, today will be as equally as hard as the last couple of days. But for most of you, and I do mean most of you, you're going to kill this stuff. It's easy. There's nothing challenging about today. If I showed this to pre-algebra kids, they would poop their pants. It's that weird looking. But for you guys, it's going to be no big deal. No big deal. Most of you, most of you could probably do this right now with zero instruction. Not because necessarily that, let's see, how do I want to say this? Not because necessarily that it is crazy challenging or crazy easy. It's because you understand the basic rules and you kind of see a pattern and put things together. All right, I got to show you homework. All right, your homework. Let's see, we took a quiz yesterday. I do have it graded, but Porter didn't take his. Most of you got perfect, right? Some of you didn't do well at all. And as I walk through the room, somebody over there left a resource card, right? It's a great resource. I don't know if this is yours, Ari. Great resource card. Tells me everything. Ari got all of them correctly. Or she did them all correct on her quiz. Shame on you if you could not write a resource card. Shame on you if you could not read your resource card. And shame on you if you didn't take advantage of all these opportunities to get a passing grade in my class. Enjoy your summer school, okay? And yes, I'm going to give you that same silly speech over and over again because I don't want you to go to summer school, right? And right now we can fix any mistakes that you have right now. Spring break, guess what? It's kind of too late by spring break. You got an F for the previous 2 quarters, and you currently have an F by spring break. You kind of already signed up for summer school, right? High school is different than all the other ones. You go to the next class regardless if you pass or fail. What you don't get is credit for passing, and you don't pass high school without the credits. You get D's and higher, you get credits. You get D's, well, there's not too many colleges that will say, yeah, come to my college. You're a D student, right? Right? So well, get the best grade you can. But I'm just saying, for the students that are failing, and I do have some right now, we got to fix things. And now we can fix things. It's only the first week of October. But the 3rd week of March, the ship has kind of already sailed by then. Let's fix any mistakes we have now. So one way you pass math, I can't help you with biology, but one way that you pass math is you make a resource card when the math teacher says you can have a resource card. It never surprised me. The kid that has the A in my class always has a resource card. The kid in my class that screws up their homework, Riley did, right, got everyone wrong. Yet she takes the quiz and she gets them right because she fixed her mistakes by quiz time when it counts, right? Fix your mistakes. Stay in the game. Fight. That's what that's sorry. You're not going to see that again until we get to test day. But stay in the fight. D's will get you through the class, but F's will get you nothing. Okay. And I had not a bunch of F's, but I had a couple F's.
Like, what happens if you get all straight D's?
Get all straight D's. You get a high school diploma that says I got D's. Guess what happens when you apply to college? You have to turn in your high school transcript. Right? It's kind of weird that some things matter and some things don't. You're in 9th grade, so now I can tell. I never say this to 8th grade students because some of them are, I don't want to say the word dumb enough, but some of them would hear this speech and say, woohoo, I'm going to get a D now. D's don't, it doesn't matter what you did in 8th grade. In a sense of no college, no job will ever say, what did you get in 8th grade math? But all important jobs, all colleges say, what did you get freshman year high school math? Oh, I got an F. I had to go to summer school. Okay, you're not coming to my college. You're not getting this job. Mr. Surratt tells a story of his wife, who the current job she had in, they literally said to her, why, I forget what the grade was. Ask Mr. Surratt tells the story. Why did you get a C in this class in high school? This is a permanent record. I mean, as much as a tattoo. I can't walk away from what I did in high school. I can't. What I did in high school, it's a physical thing. It walks with me to every job. When I applied for this job, I had to turn in what I got out of high school. Okay? Luckily, I did fine in high school. I'm not ashamed of my high school record. Freshman year, I had the lowest grade I had was an F, first quarter German. That's the lowest grade I got in high school. That was my wake-up call. I better shape up or bad things are going to happen to me. Right? It's a permanent record. It doesn't leave you. You can't, like, erase it. Right? I got to add this on a positive note. But for those of you doing great, yeah, this is what's going to get you into a great college. You can get you into a great job. The fact that you're kicking butt and taking names. For the rest of you, let's fix it before it becomes a problem. Why was that speech so long? I don't know. All right, homework tonight.
For a long time.
Probably. Oh, it's on freeze. That's why. It was. There we go. Hey, as some of you are looking at this sheet of paper, some of you probably already know what to do. Nothing crazy today, but this is Algebra 1. Sorry, keep kicking your foot. Nothing crazy today. It builds upon what we've just done the last 2 days or the last 2 or 3 classes. And then Tristan, while you're walking back, tuck your shirt in. And I'm going to help you get that good job of wherever you're going to work, because if you show up with an untucked shirt to your first job, they're going to fire you.
Is it untitled? Yeah, I know. God is there.
There are hard life lessons, there's easy life lessons. Tucking your shirt's an easy life lesson. The hard life lesson is to wrap your head around the fact that no employer owes you anything. It's your job to convince them that you are worthy of their job. The employer can just slam the door in your face and say, leave, right? It's your job to impress the employer. One way you do that is by dressing nicely, showing up, being able to say a sentence without a curse word, being able to say a sentence without, hey, yo, dude, right?
Yo, broski.
Right? You're not getting the job if that's how you talk to your employer. All right, but you guys get to learn all those lessons.
The hard way.
Some of you will definitely learn it the hard way. Some of you will learn it the easy way. I know for me, I was scared pretty much of all my employers until I found out that they actually needed me to do their job. And then, you know, you kind of turn the tide on them and say that, you know, you're in the best position when they need you to be a worker, right? The worst one is where they don't need you to be a worker, and so you got to convince them that they should hire you, type thing. When there's 400 people, I mean, you've probably seen pictures of the paper where a job opens up, and it's always news when something opens up and they have literally people lined up around the block to get, you know, 50 jobs. You know that big building by the airport, Amazon.
Yeah, the Amazon workplace. Yeah.
They're gonna literally have people lined up like to a mile deep. Probably, I'm exaggerating slightly. Amazon can hire whoever the heck they want. You know, what are you gonna do to impress them? Hey, here's my F in Algebra 1. Hire me. They're not gonna hire you. They're gonna hire the person who got the A. Right?
That's why you kill the person that got the A.
Then guess who your employer is?
In this.
The Board of Prisons, right? So you get to talk with Tristan's mom and dad, right? All right, here we go. Quick reminder. Standard form is when you write a polynomial in decreasing order. Decreasing order. So when we write our answers for everything today, we're going to write all our answers in standard form. That means you look at the power, whichever power is highest comes first, so forth and so on. All right, so this right now is written in decreasing order. Look, it goes fourth, third, second, you know, first power and no power, constant. Right? All right, this one right here is also written in standard form, although it's missing its quadratic and its linear term, right? It's still written in decreasing order. All right, today we start the big stuff in algebra. From now until whatever the last math class you're going to be taking, you're going to be multiplying polynomials. When you multiply polynomials, let's start off with an easy one. We're going to multiply a monomial times a polynomial. Why are you not paying attention? Okay. We're going to be multiplying a monomial times a polynomial. So let me describe what that looks like. Here's what it looks like. What thing is out front? Okay, what thing is out front? Just plain old x. X is a monomial, right? It's one thing. Eventually, tomorrow's class, we're to talk about multiplying, say, a binomial times a polynomial, or a trinomial times a polynomial. Much more complicated. But today, nice and simple. We're simply going to be multiplying a monomial times a polynomial. This is a quadratic trinomial. Quadratic to the second power. There's 1, 2, 3 things. Trinomial. Some of you couldn't do that on the quiz yesterday. Okay? Monomial times a polynomial. Okay? Okay? Remember, when we multiply, not yesterday's class was a power to a power. What do we do with exponents when we multiply? This was 2 days ago class. What do you do with the exponents when you multiply? You add them. So for those of you that can remember that class 2 days ago, hopefully, then all we're doing is adding exponents today. We are not doing power to a power. Right? That was yesterday's class or last class. So you can think of this as the distributive property on steroids. Right? Before we just had like a binomial on the inside. Now we're going to have a trinomial or a quadrinomial or a polynomial in basic terms. We have lots of things on the inside. So we need lots of arrows. All right. Once we get to Algebra 1, I kind of shorten the notation. It's expected that you can do this in your head. Is that too much of an expectation? Can you multiply these two things in your head? What's the answer? X to the third power. So even though for this first example, I'm going to write the two things we're multiplying, this is just scratch work. After this one example, I'm expecting you to do this in your head. Okay? X to the first times x to the second is x to the third. We write x to the third. Second arrow, that's what I'm multiplying. What am I multiplying? X to the first times 2x to the first. What do we get?
2x to the second?
We write that.
Oh.
The third arrow, I'm multiplying x to the first times -3. What do we get? -3x, and we're done. That's all we're doing today. It's simple.
Wait, so
We don't teach this to pre-algebra. We only teach this to Algebra 1 and higher. Okay? What do you mean a base? And then that thing goes along with it. Okay? So, I'll show you an example again. So, what's the thing out front here? -x. That's what we're going to be distributing to the inside. So, I'm not going to write the two things we're going to multiply. You're going to do this in your head. What's -x times 9x to the fourth? What's -x times 9x to the fourth? Aiden? Okay? So for some of you, you are going to need to do scratch work. So for those of you that need to do scratch work, you do scratch work. For those of you who are like, what in the world would I need scratch work for? Then don't use scratch work. So don't get it wrong. So for those who need scratch work, what are the two things I'm multiplying, Aiden? Okay. No. No. You're getting closer and closer each time, but you're not there yet. I'm multiplying -x times 9x to the fourth power. What is the number in front of x? So what are the two numbers I'm multiplying? It's a -1 and 9. That would give me -9. And then x times x to the fourth would give me there's a 1. 1 plus 4 is 5. It would give me to the fifth power. I'm just going to say, as a class, we're not at that speed. We're at a much faster speed. Aiden, we need to work together, you and I, right? Tutoring, after school, student advisement, something. The class is ready to run, right? We're not walking. Yeah.
if it was -2x.
We'll talk about, let me wait till we get an example like that. All right. First arrow is that. Second arrow. In our heads, Aiden said there's a -1 in front. -1 times -2.
That's plus. So it's
Plus 2. X times x to the third.
X equals
How many people got that in your head? You can do that. Okay? Mike, yes, no? Lily, yes, no? You can say no, it's fine, right? Last arrow. Negative 1x times 7 would give me,
negative 7x to the first.
and we just leave off the first because we're lazy. Okay?
We're efficient.
We're efficient. Who's lost? Okay? No, I'm not even gonna ask who needs to do the scratch work. If you need to do the scratch work, there's no harm in that. I'm just saying, as a class, we're not for this part. Scratch work is kind of a bridge too far of asking you to do, because most of us can do that in our heads. And yes, I'm encouraging you to do that in your heads. But if you need scratch work to write what you're multiplying, then you need to do that. All right, so this is a whole bunch of people's questions. What if there's another number out in front? Chris, what are we multiplying?
Negative 3, 2. Like negative 2 times negative 3.
Negative, oh, he's already doing it piece by piece. In general terms, what are we multiplying?
Negative 2x.
Perfect, good job. Negative 2x times that thing. Now, to the mechanics of that, that's what he was doing, is we're going to do number with number, variable with variable. So, Chris, what are the two numbers we're multiplying?
Negative 2 and negative 3.
That would give me
6.
Okay, so we write 6, and then x times x to the third gives me
X times is x. No, x1. Oh, wait.
when we multiply with things that have powers, what do we do with the powers?
Them alone.
We add them.
All right.
So x times x to the third is
3x to the 4th.
okay. So we got 6x to the fourth. You got to be brave and stop me if you're lost. If not, we're moving on quickly. Kaylee, what's the next things I'm multiplying? That's not a 2. So what's negative 2 times 2? Okay. What's x times x to the second power? I just did the negative 2 and the 2. Now I move on to the x's. You just did negative 2 times 2, and you told me that's negative 4. I got that. We're done with the negative 4. All right, negative 4. Now do the x's. Just the x's. Because 1 plus 2 is 2. We have to add them. We're multiplying. So when you multiply, you rewrite the base and you add the exponents. Okay. Mike, the last one, what are we multiplying?
Oh, just right.
Okay, if you're going to make a mistake, it's probably going to involve negatives, right? Negative times a negative. So what do we get? This is where you're going to make your other mistake. Remember, when you're multiplying variables, you add the exponents. So you get, what are the exponents of the things you're multiplying? Well, x is to what power? X is to what power? So when you add, you get? Yes? Okay, no, it's fine. I mean, I wouldn't expect many people to be asking questions right now, but I just want to make sure you're not asking me questions because I'm going too slow, right? If I'm going too fast, then you got to slow me down. All right, box one, let's do this one together. Here we go, box one, box one, box one. Aiden, what's the first thing I'm multiplying?
3x to 2x. Or 3 and 2.
Okay. For me, I draw the arrow. Even though I could do the whole thing in my head, I'm still going to draw the arrow. The arrow helps me identify the two things. What am I multiplying? Say it again, Aiden.
3 and 2.
What do you get there? So write equals 6 on your paper, and then do the variables. X to the third times x to the third. We are. But you got to be the one that remembers that, right? Okay, if I'm the one reminding you, then you got to remember that when we multiply with variables, we add the exponents. All right, second arrow. What do you got, Nathan? Second arrow. Well, what's the number? What's this number? Okay, so multiply the numbers. Because 3 times -1 is -4. Okay, so I'm going to write -3, and then I'm going to deal with the variables. That times that gives me you said we just did the numbers. The numbers are dead to us. Now we're just doing the variables. This variable times this variable. If I were to write this, you did this 2 days ago. I, in fact, gave you that problem, and you told me the answer was?
It was x cubed. Well, x is the third part.
Which is?
X is the sixth part.
Okay, so
Or I'm just getting confused.
you are getting confused. There are 2 rules. One deals with multiplying. One deals with power to a power. Yesterday's class, 2 days ago class. Yesterday's class, what did we do? We multiplied. 2 days ago, we, all right, so what's the answer? Okay, x to the 5th. Now, combine that with your -3. Hey, this is the learning process. It's ugly sometimes, right? But that's the learning process. If you're willing to engage in the learning process, you will get this. If you're just going to sit there and like, I don't know, don't care, well, remember what I said the first 10 minutes class. All right. Don't need to hear that again. Last arrow. What do you got, VDH? Numbers with numbers, variables with variables. Look at the arrow. That's the green one. Multiply the numbers. Do you see that the green arrow goes from a number to a number? Just multiply. That's it. Positive or negative. So I put plus 12, and then I multiply the variable with the, oh wait, there's not a variable. If there's not a variable, then you just rewrite what you got. So what am I doing? And it's positive, right? Stop me, or we're moving on. Okay, I think we need to do these together. I usually have these to do by yourself. So let's do these together. Sierra, you want to try one? Okay. Rylan, first one. Tell me what to do.
3x squared times 3x to the 4th power.
That would give us,
6x to the 7th.
because 3 times 3 is 6.
No, 9x to the 7th power.
X to the what?
6th power.
You're the one that wanted me to make the room cold, and now it's frozen your brain. You can't do that.
Actually, your brain actually was better in cold air.
Well, well, prove it to me. Get the next part right.
3.
So he finally decided it's 9x to the 6. I agree.
Right, 3x squared times 5x squared, which is 15x to the 4th.
Okay, and the last arrow?
12x to the 2nd.
All right, he got that one. He killed it, except for the first part. Did you guys get that? All right.
Yeah.
Say again. Yeah, so the last arrow would be this times this, right? Well, this one doesn't have a variable. It still has numbers. 3 times 4 is a positive 12. And when there's only one variable on one term and not the other one, you just rewrite the one you give it. Okay? Any other questions, Amy? Okay. You want to try the next one? Okay.
It'd be -6x to the 4th power.
What is it? Tristan? Oh, that's right. I said Tristan was going to get this one.
It'd be -6 to the 4th power. Plus
-6
x
to the,
4th power.
keep talking,
Plus 18
because a negative times a positive is a positive.
negative
-18,
x to the 6th power.
keep talking,
Plus 12.
because a negative times a,
negative 12x to the 2nd power.
I'm not going to make something silly that says like, well, if Tristan could do it, you all can do it, but I'm just going to say, no.
He wants to say it.
This is what algebra, I mean, I'll just have plenty of kids, you know, the smart ones and the opposite of smart, right?
It's at least slow.
But I'll have the kids that try, Tristan right now is trying, and they get it. It's like it's just Algebra 1. It's just a few rules. But my point of the sentence is that if you don't try, there's just no way. It's just weird stuff. Especially the Nathan issue right there is that I will teach you one day to add, and the very next day I told you to multiply, and then it gets all jumbled in your head, right? That can happen absolutely 100%. It's not like we're dealing with, I don't know, nice, easy stuff anymore. The rest of, at least through high school, the math never gets any easier. It just stays this ugly, right? If you love math, you get a great time. If you hate math, well, then you're in for another 3.5 years of torture, right? So the question is, how can you make the torture less tortuous? And I'm going to submit to you that comes to just paying attention. I'm not going to claim I'm going to make it fun. I'm not going to claim I'm going to say, oh, this is so relevant to your life either, other than that one speech I gave you about, well, this is what we do to all high school students. We teach everyone the same stuff so that you can make a decision when you're 18 of what you want to do with your life. Okay? You want to work at McDonald's? I've already taught you way too much math. Right.
We're going to have to do this at working at McDonald's.
Absolutely not.
It's the Burger King formula.
Yeah, but if you work the Burger King, yeah, you got to do this. All right. Here we go. Last one, Rowan. Do it real quick. How much? Okay. Yeah, squared or to the second power. Very good. All right. I just really need you guys to either affirm or not affirm that, okay, I see the process. Yes, I understand. I'm probably confident I will make a mistake with this, but I understand the process. Okay. Your mistakes will come when you're distributing negatives, right? Negative times a negative is always a positive, not a negative. Negative times a positive is always a negative, not a positive. That's it, right? Negative times a negative is a positive, not a negative. Right?
Or you could just say
a negative times a negative is always positive.
Or you could just say different is bad.
Different is bad, same is positive, right? But that's only for multiplication, division, not for addition, subtraction. Haley? Okay, in a second. Okay, now we just finished the easy ones. They do become slightly more challenging. The way that they become slightly more challenging is they just make it more complex. It's not that the rules change. It has become slightly more complex. Do you see this one? Okay.
I don't.
Okay, so this one is just slightly more complex. It's not any more challenging than the previous one. It's actually the same amount of work, but it is absolutely slightly more, well, it's visually definitely different. It's visually definitely different. It is, you will treat it, listen please, listen, you will treat it as two separate problems, but they're all in one problem. Okay, so watch how I do this. If I cover up, we go from left to right, and I cover up the minus x times 9x, well then it just looks like the previous one where you have a monomial, in this case times a binomial. So we're going to treat that part, the left side, the same way. We're going to distribute this to the inside, okay? Let's see, negative 2x times x to the third would be negative 2x to the fourth. And then the second arrow would give us negative times a negative. So plus
2x to the second.
Okay. And then we're going to do the same thing with this. What's x times 9x?
Negative 9x.
9x squared with a negative in front of it, or in other words, negative 9x squared. So that one's not too bad, except we're not done. Now look what it says. It says something to the fourth, and then it has two things to the second power. 4 days ago, we did apples with apples class. The apples with apples class said that if you have two terms that have the same variable to the same power, you are allowed to add or subtract. All right, I apologize, Nathan. Here's third rule. When you're adding and subtracting variables, guess what you do to the exponents? Nothing. Okay? So there's actually three rules here. There's power to a power, multiply the exponents. There's multiply, add the exponents. And then there's add or subtract, do nothing with the exponents. that's what you got to keep track in your mind. Okay, that's what makes Algebra 1 not so much fun.
That's on.
Unless you like rules. And if you like rules, then that's what makes Algebra fun. Because there are rules. The rules don't change. You just follow the rules. Hey, what's 2x squared minus 9x squared? Because there's more positives than negatives. Negative 7x squared. So those two you can group together. All right, stop me if you were lost in what I just did there. We did some multiplication, distributive property. We did some adding and subtracting. What you can't do is you can't add non-like terms. Non-like terms would be different letters, Aiden, different letters, or same letters to different powers. I can't add that 4 to the 2 here, but I can add the 2 x's that are to the second power together. Haley, stop me? Yes? No? Okay. Do you understand where I got this from? Okay, then all I did was red arrow, I grouped these together. A positive 2x squared minus 9x squared, which will give me negative 7x squared. Okay, does it what? Oh, very good. Let's see if we get one like this. She said they don't have to be physically next to each other to group them. The answer is, oh, gotcha. Right. Yes. All right, let's do box 3 here. Here we go, box 3. This is as complicated as it gets. This is deep into Algebra 1 right here. Right? No way in heck would I give a pre-algebra student something like this. All right, first arrow gives us what? Negative 22x to the, okay. Second arrow gives me 44x to the third, and it's positive. All right, now we got to do 2 more arrows. Okay. So this would be minus x to the 1 plus 1 is 2. Okay. And then this arrow will give me
5x.
Negative times a negative. Positive 5x to the.
I get this.
Stop me if you didn't get that. Tristan was like killing it today. Killing it.
And
Okay.
then you combine like
Well, which ones are the like terms?
5x,
5x
x3
third.
and 5x.
See these two? They're because they're both x to the third power.
And when we do those, we subtract.
Well, let's see. What does it say to do? They're both add.
Multiply.
No, we're going to add.
No, I meant the exponent.
No.
What?
Okay. So Nathan, what are the 3 rules again? Power to power we multiply we, and when we add and subtract we do nothing.
Oh, I forgot that was a rule. This is the rule.
Power to power, we're going to multiply the exponents. Multiply, we're going to add. And add, we're going to do nothing. And I agree. I mean, those words coming out of my mouth, I just understand why that would be confusing. Okay?
Okay.
For those of you that like rules and follow rules, there's cool rules. For those of you that question rules, which we have a few of you in this class, right? It can be troublesome. All right, 44 and 5 is 44 and 5 is
48.
49.
I came close.
okay. And remember, we're going to write the answer in standard form, so that's why it goes 5, 3, 2.
5, 3, 2, 1.
I actually would never count it wrong if you didn't write in standard form. You're going to find out that we write things in standard form when we get to the next chapter for a reason. It makes it easier.
Okay, so how
Certainly
do you
doesn't-
do 2 variables now?
2 variables? I don't have one of those. We got to do one more like this.
No.
3 minus 4.
All right. Here we go. 3x times negative x squared gives us 8. And I don't see the pencil moving at all.
3x to the power minus 4x.
Tristan is just yelling out the answers to me in my ear, and boy, I really want to tell him to shut up, but he's telling me the right answers, so I'm torn. You are going to give me the answers. Go for it. Negative 3x to the third. Good job. Do it. Yeah, but you added the 3. We need to add the power of the x, which is 1. So 3x to the, I know, but it's really, yes. Yeah, but we don't add the 3 to the 4, we add the 1 to the 4. The power is what we add. So 3x to the 5th
And
Well, we're gonna do that one. Whoa, whoa, whoa. Multiply. 1 times 4 is not 3.
4.
Okay, except it was negative 1 times 4, so it's
No. Negative 4.
x to the right. Okay. Now, everybody else, we look. Are there any like terms here? This one and not the other 3. This one.
I'm at the 4.
Oh, you meant this 3? That 3.
Yeah,
I agree. Okay. All right. So, hey, a negative 3 and negative 4 turns into
-7.
-7. So negative 7 x to the 3rd. But if I write them in decreasing order, this one would go first.
Yeah, 'cause it's negative.
Not so it's negative positive that this is a higher power.
Wow. Why is it on night?
Why do we add those?
Same or different signs.
Same.
That's why you add. Oh. Go ahead, Kaylee. Okay, good.
But why do you get based on powers?
Well, you're both talking at once now. Because they're both to the 3rd power, they are like terms. So your last step, when you're down to just addition, subtraction, there's no more multiplication. You look to see if you have any like terms. So we look at the powers and the variables.
Michael. All right. Why do you do it based on powers and not based on base? Why do you not base it on the base instead of the powers?
So in terms of why, other than me just saying this is the way it's done at this stage, I gotta leave it at that. I'll just show you next chapter. When we put things in standard form, it allows us to do this process of factoring pretty easy, which I don't have time to explain right now. But I will. Right.
After class.
And I also will tell you this. No, this is a chapter. This isn't a 5-minute explanation. I also tell you this. If you had written these backwards, if you wrote -7x to the cube plus 3x to the 5th, I'd give you full credit for it. Okay? But next chapter, when we're factoring, you're going to want it to be in standard form. Yeah.
Please hurry so we can get the last variable.
Well, Josie, tell me the answer to the bottom of box 4.
All right. Let's do it.
What?
I want to get to the.
All right, go.
All right. So you have to do the -5x squared.
How about you just tell me the answer?
I just do
I
that.
know, but just multiply.
I'm doing it in my head. Give me.
I bet Lance will get it faster.
Yeah, I got this.
Oh no, I wrote 3.
-15x to the 2nd is the first one.
Okay.
I already got that.
Wow. Okay,
Stop flipping.
Keep talking.
Plus,
10x to the 3rd.
Yep.
Keep talking.
Minus 5x to the 4th.
Keep talking.
Plus 12 minus 12x to the 2nd.
Oh.
Any like terms there?
You got the 2's.
Negative 15x and negative 12x.
What would that give me?
Negative.
Josie, it's simple. It's simple. It's simple.
27x to the 2nd, 3rd, and to the cube. Yep. That was
27.
words.
You didn't get it right either time.
26. 27.
It's the 4th.
So
No, you
it's
don't add those.
27 squared.
it's not.
Negative 27 squared.
No,
It's not.
It's not.
What?
Negative 3x squared minus.
Negative 27x squared. But we got to put it in descending order. So the 4 would come first, then the 3, and then finally the 2.
I said cubes, so I was kind of right.
All right. So Josie, who's got eggs in her pants, wants to see a different method.
I was thinking.
No,
All right.
I want to see where it's A and B.
I got you. We'll get there in a second. All right, look at the board. I set you up for success later on. Most of you are going to look at this and say, that's dumb. I would never do that. I would agree. But I do want to introduce you to a different method of doing this. Some people, when they think of multiplication, 42 times 7, what do they normally do?
7 times 2 is 7 times
They write it like this, correct? Aren't we just multiplying things? So shouldn't we be able to do exactly the same thing? The answer is we can. Now, I will just preface this by saying I don't expect to convince any of you to do it this way for this one, but in 2 days, I'm going to have a lot of converts. Okay, so we can do it's called the vertical method. We can take the one that has the most terms, put it on top. So the one with the most terms, we put it on top. The one with the fewest, we put it on the bottom. And then we do it just as we do this. What's the first thing I multiply here? 7 times 2. So what's the first thing I multiply here? This times this. So if you want to follow this, it's called the vertical algorithm. If you want to follow this vertical algorithm, then you just do what you normally do, like 42 times 7. That times that is this. This times this is that. This times this is that. It works. Okay. That's called the vertical method. So, show Josie what happens when we have multiple terms. We can use the vertical or the non-vertical method. Pick one. You'll get the same answer, by the way.
The one that we've been doing so
The
far.
non-vertical method. Okay, I got to multiply that times that. Hey, what's this number?
-2.
What's this number?
1.
What's 1 times -2? So we get -2. I did this vertical method. That's why I'm doing it like this. What's a times a squared?
A third.
What's
And then
b times
second.
b?
B is the second.
All right, then we do that arrow, and then we do that arrow.
-6.
I got it now.
Right?
That was easy.
Plus 6. Bingo.
Yeah, yeah.
All right. So I will end this on a negative positive note. Most of you guys did very well. That was good. Some of you I still haven't convinced to pay attention in class. I'm just saying, you're setting your course today, the first week of October, towards summer school.
I'm smart.
Maybe it's not only for Algebra 1, it's for others classes. You've chosen to come to a challenging school. You're going to be challenged here.
I wish I chose right.
Yeah.
I'm
Well, I did it as a vertical method, so.
I'm confused on this. I'm confused on
Ron, I re-speak. I made something that's going on.
Yeah, so we've got a negative 15 and a positive 12.
I'm that good. I'm that amazing.
You made a nice quote, and I called it rainbow, and now it's going on my game.
12
Did I
is
see it?
Yes, you can.
I did.
3. More negatives, more
Big
positives.
time. This is the highest I'll ever get.
Negative, that's why it's. Here's my.
Sorry.
Oh, I put the wrong one.
Toaster
Yeah,
pad.
because it was more negative than positive.
So I did this right.
It's,
Thank you. Talking about geometry or algebra 1? When did you not do your homework?
No, I did it. I had lost it from yesterday. Tried to redo it in class.
You talking about the one from yesterday or the
The
one?
one that was due today, I had lost it.
Oh, well then give it to me. Thank you. Because that's what this was.
Why did we?
That's a negative times a negative.
Sorry.
So, are you already on Microsoft Teams? Go to your screen device teacher. If you don't already have your logo, take it. Take it. Then you just need to go on to the class. But I always posted it the night of the day. You're gonna miss tomorrow, so tomorrow by 8 p.m. you'll see it. Come here. I'll show you what it looks like. Well, actually,
Downstairs, right?
I'll project it. Yeah, go. So this is what it'll look like. So when you go on Microsoft Teams, you're going to have all 7 of your classes pop up, right? Have you been on it or no? Oh, Haley, I'm going to shut you off. Any questions?
No, not that I know of right now.
Sweet. See ya.
Yep, bye.